Hello everybody and welcome back to the repair channel. I have just gotten out a Mario Brothers circuit board set, and this one, the notes on it were that it works, but everything is like in slow motion. And sure enough, it works, but it is in slow motion. Kind of strange. So what we're going to do is check the sync and timing signals, starting with the game clock, and try to just work from there. So I'll turn on the little scope and we'll start poking around. This is new. Well, this computer is 10 years old. But yeah, I've got this up now. I'm going to be doing my schematics through right on my computer here. So I'm going to go ahead and pull up the Mario Brothers schematic and take a look at the clocking stuff. Well, I got the Mario Brothers PCB figured out, and I did it off camera. I kind of forgot to do any recording of the diagnosing or anything. But I got to thinking, I slept on it overnight because last night I was kind of stumped, and I was like, okay, this has to be an issue to deal with the CPU. Because the CPU runs the show, right? Everything, the CPU is the center of everything. Everything is in slow motion. So it had to be something to do with the CPU. So I just started looking at the CPU circuit right here. And I wanted to look at the control lines to the CPU. And what I found was NMI, this 4D flip-flop, was just hammering too much on pin 9. It was toggling more than it should have based on the inputs and the clock and everything. It was toggling, but it was just toggling, I think, twice as fast as it should have been. So I replaced it, and that fixed the board. So it was being interrupted twice as fast as it should have been, and that's why it was running half speed. So just for completion's sake, I will go ahead and set up the camera and play Mario Brothers. there you have it. So I'm going to be moving right into a let's do a punch-out repair next, and I'll just combine the two. So I'll let this one run for a few hours, and then I will go ahead and grab a punch-out board, and we'll look at that. Alright, I know I said I was going to grab a punch-out board, but I'm not. I'm grabbing and doing a Donkey Kong 4-board stack. And it is missing some parts on the soundboard, which I don't care about right now. I'm not even powering the soundboard up right now. I just want to get, first things first, video and stuff working. So I've got it all hooked up. I had to put a power connector on here because I didn't have one. So I'm running this on that power supply. It's got a strong -5, and that's what you need on this board. Because look at this. This board is all ECL almost. Alright, so let's go ahead and fire it up and see what we get. Nothing. Nothing at all. Okay. So I'll go through and do some power checks, check my voltages, and then I guess it'd be a good place to start looking for some clock signals and that kind of stuff. So let me get set up and we'll take a look at some voltage readings. Okay, we got ground. This is going to be our -5 capacitor right here. Actually, no, that's our 5-volt capacitor. There's the -5-volt capacitor. So we got -4, which that's okay. And 5 were high. So I'd like to turn that down a slight bit. See what that did. 540. Keep on coming down. $498, that's better. And 384, that's not good. We're going to go a little higher. This thing is such a power hog. Didn't move. Just slightly. 512, 391. Come on. There we go. Let's just see. 5.3 and 409. I don't like 5.3. .25 would be nice. 5.22 and -4. We're just going to have to go with that. That's a bad thing about these Donkey Kong boards, is they use so much -5, and these power supplies just are not equipped for that -5. They're just not. They can't supply the amount of current that this thing needs. Maybe the Donkey Kong power supplies are probably engineered with a higher supply, -5, but these switchers are not equipped for this. But they do, they'll work. It will work, it's just not ideal. Anyway, we got nothing on the screen, so I'm gonna go ahead. I got my voltage where I want it. I didn't check 12. I'm not worried about 12 volts right now. I'm sure it's fine. Famous last words. So this is the clock board. This is where all the clocking is generated. So I'm going to just kind of probe around on this clock board and see. And the bad thing about it is it also, all of the stupid ECL, all the clocking is through this ECL junk. I need to find this clock board. I believe this is it right here. Yeah. TKG306. This is TKG203. .306, 306, TKG 2 and 3. Know what this is. Oh, that's Donkey Kong Jr. Alright, this is the one I need right here. TKG 3. This isn't TKG 2. Unfortunately, I don't have that. Clock board. Hopefully these are all pretty much the same. Okay. Anyway, let's look. Here's a test point for an oscillator, and there's nothing. There's nothing off this crystal. Well, there was something. I can't see. There is your 66. Boy, that thing says 73 megahertz. And it's coming up 72 or whatever. Yeah, 73. 73.5. And it says it's supposed to be 73.7, so that's good. This is going to have to come up because there is no oscillator. So whatever is under here isn't seemingly doing anything. Now, yeah. There's a couple transistors underneath there. And it comes through this little windy transformer here. And through a capacitor, a 10 picofarad capacitor. That's got to be underneath here. Alright, that's the output side of it. This is the output side. This is the input side. So you have test point 1. And then it comes. This must be ground. Yeah. That's ground. This is the supposed oscillator. And there's nothing there. Nothing at all. Okay. Yeah, I'm going to have to remove this and follow this crystal and see what's going on. So this is going to have to come apart. And we're going to have to remove this board, get it off of here, and find out why we're not getting any crystal. The crystal seems to be oscillating because I see yeah. It seems to be doing something. So let's turn this off. I'm going to unhook this. Get this. Get this board off of here. Get this cover off of here so I can see under here. There's obviously something is not right in this oscillator circuit. Okay, I got the board set out on the table, and I had to make this connector right here because when these are folded over, this one just jumps over and runs power to this board. The video board down here, when it's folded under this, there's this little guy right here, that little jumper runs power to this board. So I basically just made a little jumper to go from that board to here so that I can lay the boards out. And I took that off, and oh, I've got a chip jumped over that. Anyway, this is the oscillator point. I had to kind of fix my Now that don't look good, does it? That's right here. This test point for the oscillator is right there. And it goes through this transformer. This is ground, actually. And then it goes over here. And then it goes through these that's those resistors right there, and it comes over and goes into these 116, this guy right here. Now I had this jumped over here. Watch how, remember how this looks. Looks goofy. If I jump this chip over this 116, it really straightens that out, doesn't it? It actually looks pretty good. So why is that? Makes it oscillate. Let's look at pins 9 and 10. I think that's 9 and 10. 7 and 10. No, I gotta move this. Let's. You know what I need to do? Let's put my ground reference at -5. Now, let's look. Is that -5? Oh, that's way up high. That's -5. Now that's way down low. Let me get to where I can actually see these signals. I gotta mess around with my scope, and I'll be back. Okay, I have the outputs of this little transformer. Remember, this is the input, this is the oscillator in, then it goes through this little transformer. That's right there. I'm looking at the right side of that. That's the output side that leads to all of this. That's this side right here of this little transformer. And our oscillator is good. We have a perfect looking oscillation there. And that looks like it goes to I don't know what happened where it's not looking so good no more. There it is. There it is. But it looks like it goes to pin 5. And that looks good. But if I remove this chip, that nice looking signal is still here on the output. And it's still here. Well, I'm actually getting something now. Where's the 160? There's 161s on this board, I think. 64, 164. There's 161, 161. I think there's supposed to be... I don't have a good schematic for this. This is a different schematic than what I have, and it's kind of hard to deal with. But I really believe that my chip problem is right here, or it's in this 136 stage. See, it shows me, it shows 3 of these 161s, and then there's all this ECL stuff here. It looks like the next generation of this board got rid of a lot of this ECL. So this is a really heavy ECL board, and I really do not like it. And yeah, the problem is one of these ECL chips, and I just gotta, I think, I'm not sure, but my schematic doesn't really even work for this board, because this shows that output going to pin 5 on this, and then on this one it shows that output going to pin 7, or that might be pin 9, I don't know. Yeah, I'm not sure. It's hard to do. I don't have a good schematic for this, and I don't know if I'm gonna, do not know if I'm going to carry on with this, because I just don't have a schematic, and yeah, I don't know. We'll see. There is another board set. There is another 4-board stack set in there I might take a look at. But this one I may not mess with, because I just don't have schematics for it, unfortunately. I'll figure it out. Let me think about it. Well, I think I've found something that's quite close to what I need. This is radar scope schematics. Because this was a radar scope that was converted to Donkey Kong. So with this, I was able to verify all of this and the first driver chip. This chip is fine. And I've followed, let me move this. Maybe what I should do is install OBS so that I can screen record on my computer, so that we can have good quality. That's what I'm going to do for my videos from now on. Just bear with me for this video, but I'm going to install OBS on this so that I can actually record what I'm doing on this, and then, you know, edit it into my video. Anyway, this is what we're looking at here. I was able to verify, where's it at? Where's all that stuff at? All of that. This stuff right here, all of this, these theta signals were good. All of these theta signals coming off were good. So I wanted to just follow those theta signals and see some of this stuff right here. These are 1036s. Look like they're a sort of counter. Not a sort of. They look like a counter. This HP is obviously, I think, what's clocking these. I'm not exactly sure. No, this is what's clocking them. This theta 31. Theta 31 is what's clocking them. And all of these signals were good. The 31, the HP, all of those were good, coming off of that circuitry that I looked at. And then I came over here to 4F, 4E, and 4D, and these are the counters that are making the horizontal counts, right? These are the horizontal counts. These 125s are level translators. So these are taking the ECL level and converting it to TTL level. So on 4A pins 5, 12, 4, and 13, I should have TTL level signals on all three of these three chips. So that's what I'm looking at right now. So we'll look at 4A. 7 is the input. And this is 4A, pin 7. Okay. That's pin 7. That is the input. And that's fine. And then I'll go over to the next bit, which is pin 11. And these are ECL level. These are ECL levels. There's that one. It's not as big. It's not as pronounced, and maybe that's a problem. I don't know. Is that 7? And that's that one. And then the next is pin 3. And it's right there. And if I move the trigger, it will straighten up. And the same with 10. There's 10. Okay. Let's do 4B. 4B is right here, and we'll look at pin 7. And I just need to move the trigger, which I can't really do right now. Pin 3, what is that? 3? 5. There's that 3. Seven. I don't know if that's 3. I think it's pin 3. 15 and 11. Right. Now what I want to do is I want to hold on, let's say, pin 5. And I just want to hit auto. I want to hit auto on this. And now it's going to go back. This is TTL level. There we go. This is TTL level. Let me grab the camera. Okay. Pin 5. That's TTL signal right there. That's 12 megahertz. And now pin 12 should be the next one, and there's nothing there. There's nothing on 12, there's nothing on 4, and there's nothing on 13. Now I don't know if it's because those signals were small, or if, I don't know, so it might actually be this right here. It might be this 136, or it could be this chip holding those signals low. I'm not exactly sure which one it is, but I'm going to continue looking at these. I'm going to look at these TTL levels on these and see if those are coming out at all. So the next one is 4B, which is right here. And first we'll look at pin 5. And there's nothing there. And then pin 4, nothing. 13 and 12. Okay, so yeah, we're not getting anything there. I need to go back to TTL or ECL levels. So I'm going to hold on pin number 7 and click auto. And it's going to adjust to the ECL level. Okay. Okay, there's the ECL level. Alright, that's pin 7, here's 11. And that is smaller, but it's not that much smaller than 7. And there's a carry out, it looks like pin 4. And that doesn't quite look right. Is it pin 4? Yeah, it's pin 4 is a carry pin. That just doesn't look right. So this chip kind of doesn't look right to me. Not 4A, 4F. 4F, pin 4. Now I was looking at the wrong chip. That's a carry bit, and there is no carry bit. That's 4F. And that's supposed to be a carry out. 14, 15, 2, 3. 14, 15, there's nothing going on now. I don't know if it got messed up or what. Let me keep poking around on here, and I'll come back if I find anything interesting. Okay, so far I have replaced 2 parts. I replaced this guy, which was up here on the schematic. This guy right here, this 116. Because I didn't like, it should have been like 70 or some amount of megahertz out of here. I don't remember, like 70 megahertz or something like that, and then it's divided down to like 30 something right here maybe, and then it comes over here. And that is where I'm at right here. So if I look at pin 13 of this chip was dead right here too. This 4F only had 1 bit that was counting. It was this 14, and then the rest of them were just, they weren't doing anything. So I replaced that, and we'll look at pin 13 as the pulse clock. 13. And I gotta back this way off. 13. That's the pulse clock. Let me back it off one more time. Bear with me. Alright. Right there. And it looks really good. Replacing that chip cleaned that signal way up. So it was bad. And the outputs on this are 14, there's 14, 15, see this one is 12 megahertz, this one is 6 megahertz, and then over here on pin 2 we have 3 megahertz, and then 1.5 and a trickle count. So that's that. Now this one receives that trickle and it continues the count on pin 14. Let me zoom in a little bit. Okay. 14. There we go. And then 15. Yeah, 14, 15, 2, 3, trickle count on 4 right there. You see it? And then it comes over to this guy, the next one. On pin 14 we have a count. And then 15 we don't, and 2 we don't, 3 we don't. So this is the next one in line that's no good. It's another one of these 10136 counter chips, ECL. So I have to replace that guy. That is this one right here. So after that's replaced, then I got to check the TTL level outputs of these 125s. Okay, I replaced that. And now when we come over here and look at this, I'm going to start all the way over here and work my way down that way. I know I'm going to have to back this off because I already looked. Starting at pin 5. Oops. There's 5, 4. Nope, it's 512. 5, 12, 4, 13. Okay. The next chip is 5, 4, 13, 12. So 5, 4, 13, 12. And the next one is just 13, 4, and 5. So 13, 4, and 5. Thirteen, 4, and 5. 4, 5. That is 126H. It's all right. That is. It should be doing something. How about pin 6 is the input to that? That doesn't really look to be doing anything. 14, 15, 2. Yeah, 14, 15, uh-oh, 14, 15, 2, 14. I think my chip crapped out. I think my chip is bad. Because it was working and it just kind of flaked out. There's 14, that's good, that's a signal. And 15, there's no signal. So, yeah, I don't have any more of those. There's 14. 15, 2, 3, 4. That one is good. 14, 15, 2, 3, 4. That one's good. Now we've got color again on the screen. I bet you this one popped in and started working again. That's kind of what I was seeing. Nope. I wonder if it's 4C. I wonder if it's this chip that's corrupting that chip. I don't know. Let me do some thinking and I'll be back. Huh. I just swapped these two and I got garbage on the screen. So that's good. It looks like we might have bad RAM with this nonsensey, twickly stuff going on. I think that'll probably be a RAM issue. We'll see. Remains to be seen. Anyway, boy, that's... Ugh. This board was fun. That tells me we most likely have our sync issues squared away. Every now and again it likes to flake out a little bit. These pots, I think these pots are not very good. Yeah. Yeah. Anyway, cool. So I think that's enough for one night. We'll pick back up on this tomorrow, and hopefully when I turn it back on tomorrow, it will remain working. We'll see. Anyway, that is it for tonight. We'll be back tomorrow with some more 4-stack Donkey Kong work. Okay, Donkey Kong. I found that this thing was having an extremely hard time syncing and being displayed on the monitor correctly in the positioning. And I've noticed this pot wasn't even making a difference in positioning, and it was broke. Now this calls for a 50K. You can use 30K to 50K. Alls I have in the proper format, the proper form are 20K. So what I'm doing is I am adding 27K to make a total of 47K on these circuits. And how I'm doing that is I'm just adding this 27K right here is where we're looking, this 50K pot. And what I'm doing is I'm severing this right here, and I'm putting another 27K in between the pot and voltage and 5 volts. So that'll give me the extra added. I'm basically making this a higher value pot, because all I got is 20K and I want it to be close to 50. So I'll have 50K right here to move with my wiper. So I'm doing that on both of these. And what that looks like is severing right here and right there, and then just running my 27K pot between these 2 points on both of them, onto this track and that solder point. So I'll go ahead and do that and then show you what that looks like. Okay, pots installed, and here is the mod on the back. 27K resistor. put in place. So let's hook it back up and see if we can at least sync properly. Alright, we are hooked up. Got my new pots in, and I actually had to remove those resistors that I had in there and just re-jump where I had cut the traces, because it just limited the movement, and it works fine with just 20K pots. I've got it adjusted the way I want. Now the thing is this thing, when you start it up, when you first turn it on, it takes it a while. It takes it a good minute maybe to actually come up and sync, and I believe it's just these stupid ECL chips. It might even be my weak negative 5 volts, because I only have negative 4 volts as a bias for these, as a power rail for these things, and it needs to be negative 5, but I don't have a power supply that will provide enough negative 5 voltage for this thing. So yeah, I don't know, I don't like that at all, but what can you do? I don't know what else to do about it. So anywho, this looks good, but I am going to chalk that up to this coming up slow and not working to I have negative 4 volts on the negative 5 rail. You know, this is just a bad design by Nintendo, because people don't make power supplies that supply this kind of negative voltage. They just don't. See if I can grab a ground there. I got negative 4.15, and that is as good as I can do. So my 5 volts is at 5 volts. I don't want to go any higher than 5 volts on that. You know, I really don't want to crank that up any further. So it is what it is. I don't know. These stupid ECL chips that Nintendo used. Dumb design. They did eventually get away from using all of this ECL, and I've never seen one like this. I've never seen a TKG2 board or a radar scope board. I've never seen one of these, and it's full of ECL. Full of it. So yeah. But we've got a CPU issue. So I need to figure out what's going on with the CPU issue. So I do have sockets here, which is good. I can plug my Fluke into it, and I can plug the Fluke into it and make sure that I can read all of this RAM here, and maybe we can advance and find out something. I think I'll do, since I got my scope on, we'll go ahead and just kind of poke around the Z80 a little bit. Let's go to pin 6 or 26. 1, 2, 3, 4, 5, 6. It's not resetting. The clock is pin 6. Uh-oh. 1, 2, 3, 4, 5, 6. Okay, we've got that. Let's back it off a little bit. What do we have? And a little bit more maybe. And it looks like we got 3 megahertz on the clock. I don't know if that is the proper frequency. I'm going to think that it is, probably. So, ow, that is hot, hot, hot. That could be dead. That's super hot. I'm gonna try a different CPU. That's abnormally hot. Okay, CPU, put a new one in it, and check it out. And this is what I mean. It takes it a while to sync. It just does this for a minute, about a minute, and then it will straighten up. But the program is running. Donkey Kong is running. But we definitely have video board issues. We gotta sit here and wait for this to straighten up. So let me let this sort itself out and I'll come back. Okay, yeah. I turned my power supply up as much as it would go, and I got 5.2 volts on the 5 volt, and the negative 5 is negative 4.25 volts, and it straightened out a little bit. If I had a solid negative 5 volts, this would work perfectly, but I don't. And that's the downfall of this system, is the negative 5 is so demanding. It's hard to find a power supply. Maybe the original Nintendo power supply, which was engineered for this, but these modern switchers are not equipped to output the amperage that is required for these negative 5 volt rails on these old Nintendo things with these ECL chips that run on negative 5. Their power rail is negative 5. And they're power hungry. They're just power devourers. Very inefficient board. But this is what we got. It's running. We got Donkey Kong going on. We got video issues, obviously. Looks like we probably got could be character RAM issues, character ROM issues, sprite issues. Mario don't look right. We got all these B's and all this nonsense that kind of tells me we have character RAM problems, possibly. But at least we're getting somewhere, right? We got Donkey Kong. So, I think we're good here for now. And you know what? I discovered the reason why, remember I had to swap these and then all of a sudden magically it worked? That chip had a broken pin 1. I soldered a leg onto it. So pin 1 was broken off on that chip. And I just noticed it and I had to put a pin in it. Pin on it. So, yeah. Okay, that tells me that these ROMs are probably good. Our program's running. So that's probably not an issue at all. I need to flip this over so that I can get access to the video board, because I believe that's where majority of our problems will lie. Uh-oh. Uh-oh. What happened? We just lost it. Just lost everything. Oh, goodness gracious. Dead. Dead. Do we still got our voltage? Because everything seems to have gone bye-bye. Nope, we lost -5, it looks like. We still got 5 volts. But we lost our -5. See that? So it looks like possibly that power supply could not handle this board. Interesting. All right. I guess I'll have to switch over to this guy. Let me switch to that power supply and see what we get. Okay, I completely removed that power supply that was up there and wired in, made a connector basically. I took the harness that was on that power supply and just adapted it with a connector that I actually put two connectors on it, one for my AR and one for the switcher. Right now I'm just running the switcher, my black switcher here, and I don't know what just happened. Yeah, I think that switching power supply died. Honestly, I think that switcher just crapped out. Because now I've got no voltage. So let me look and see what's going on. Hey, I took my power supply, my Hakko, or not Hakko, but HAP power supply, whatever. And yeah, it burned up and shorted out this diode. The one on the left that's standing up is short, and you can see where it really burnt up the board. It fried that diode. Shorted it right out. Yeah, I can just put a couple diodes in that and call it good, but and I probably will do that. I'll just kind of I'll repair this, replace those diodes and move on, but I need to come up with a solution that I can run this board with. This thing is killing my power supplies. I got this old Sega power supply right here. I may try using that. Okay, actually, I have just decided to wire in my AR. So we're going to see how long my AR lasts powering this board. So let's go ahead and fire it up. And my AR can only do 2 volts on -5. Turn that off. So, yeah. Huh. Very interesting. Let's unplug this. This is actually power going out. Yeah, let's unplug this and fire it up. I'm just messing around. There's 5 volts. There's -5. See, if this thing doesn't have much of a load, it can do the -5. And there might be a short on this board. Who knows? Let me do a little bit of... I don't want to blow my AR up. I really don't want to. But let's see if -5 is actually short. No, it's not short. It's just the demands of this. The AR cannot supply the -5 for this. I can try my Sega supply, but that means I have to change my connector all around and everything, and it's kind of a pain in the butt. I wish I had a Nintendo power supply, but I don't. So let me figure out what I'm going to do here. Okay, power supply experiment number 3. I've got my maiden adapter for my Sega supply. So I've got the Sega supply hooked up, plugged in. I got ready to read voltage on -5, and let's turn it on. And -2.8. Not going to do it. Can't supply the power. Goodness gracious. Interesting. Right, well, don't know exactly what happened there, but I opened that power supply up, and I bought this power supply specifically for Nintendo boards, specifically for this problem. This is a Meanwell power supply. I bought it from Mauser Electronics, and I believe it was advertised as having a stronger -5 output. That's why I bought it. And I opened it up and I didn't see any parts burned up. I didn't see anything looking bad. So I hooked it back up and it's working. And it's about, I mean, it's still not great. It's still not perfect. It's 4.3 volts. Which, hey, if it keeps working, at least it fires it up and it comes right up. Now, I don't know. But yeah, you need the original power supply for this. Anyway, we're back to this. So, we're running. The CPU was bad. I replaced the CPU, remember. Program's running, so now we need to focus on the video board. Yeah. I don't believe that the CPU writes to the character RAM. I think maybe it does. I'll have to look into that. I'm going to actually look at some of my prior Donkey Kong repairs, because I know I have done fluke work on Donkey Kongs, and I need to find out, does it write to the character RAM and the video RAM? What exactly does it write to? So, I don't know. I don't remember. So we'll figure it out. But we could just have, these could be just ROM problems. This could be bad ROMs. It could be RAM. I really tend to think this is RAM related, all this random characters. So yeah, we'll figure it out. Well, unfortunately, I'm having to give up on this Donkey Kong set because it keeps shutting down my power supply. It ran for about 5 minutes and then it's going into safety for whatever reason and shutting down. So, I can't fix this. I don't have a power supply sufficient enough to even run this set. So, yeah, that just is what it is. I've got more Donkey Kong stuff that I can look at, but as far as this one, I can't do anything with it. So, I'm going to move on to another Donkey Kong set, a TKG2, the 2-board set. So let's take a look at that. This one, unfortunately, I'm just having to throw the towel in because I can't run it. But yeah, I know I did fix the no clock issue on the clock board, so that's worth something, right? And we know diagnosing the CPU was bad. And so I'll charge for just some parts and some diagnostics on this one, but not a repair, not a full repair, because I just can't run it. So it is what it is. We'll move on to a set that I know I can run. Yeah, see, I hooked it back up. I let my power supply regroup for a little bit, and it'll run it. Gotta fix. There we go. fix that. And now it's not even running, so now it's back to not running. I wonder if it's because this is plugged in. Let me unplug this board. And no, I just had to reseat these connectors, the edge connectors. And it's running like it was. So this is where we're at. And give it about 5 minutes and it'll shut down. So I just don't have a power supply that puts out. I think that you need like a 3 amp -5 supply. These 1 amp supplies won't do it. And this one might be like a 1.5 to 2 amp output on -5. But it's just not enough to do it. I think you need a good strong 3 to 4 amp output on -5 for this, is my guess. Yep, so anyway, it's kind of, I mean, it's better than it was, right? We actually have the clock working, and the CPU was bad, so I think I replaced 3 ECL parts and the CPU. I reinstalled that thing, that cover that goes over the crystal and the clock circuit, the crystal oscillator circuit. I reinstalled that. This thing, if we can get to it, that thing down there, I reinstalled that. So, replaced the pots. Yeah. So I'm going to move on to the next Donkey Kong. Well, I have actually come up with what I believe might be a pretty good solution to this. Now, these are old power supplies that were out of games, and I shouldn't be using these. I should be using 2 brand new switching power supplies. But I've got them wired in series, and this one is supplying the -5 volts, and this one is providing the other voltage. And the -5 volts that this is supplying is basically the 5 volts at 11 amps supply. But it's just the way that it's wired in series. I'm pulling the negative voltage off of this and the positive off of this. So, and we actually have, if I can do this, let's see, negative, there's your negative voltage, -5 and 5. Yeah, -5 and 5. I don't think 12 volts is on this board. Yeah, it is 12 volts. Yeah. -5. So we got a good strong -5 now. I do not like, this thing is just noisy. One of these power supplies is very noisy. I think it's this one. It's all dirty. It came straight out of a cabinet. So, yeah. And it hisses like that when it's not even loaded. It's not because it's running this way. That thing just hisses like that. But, yeah. So, I think I have a solution. But what I really think I should do is I should repair this, put a couple diodes in this, repair this switcher, and I have another brand new switcher right here, I might use those as my power supply so that I'll have a proper negative 5 volts. Yeah. Interesting. Yep, so boy, I don't like that noise that one makes. Anywho, yeah, so there you go. You can run 2 of these things in series. Basically, you run your 5 volts from the one that you want to run your negative voltage off. Connect the 5 volts to ground on this one. So your 5 volt output is connected to ground. That makes, well, however it works, it's just however it works. But anyway, that makes this one, when you have your ground on your board ground to this supply, this 5 volts will be negative 5. So you grab your negative 5 off of this. You hook your negative 5 up to the negative 5 rail on here. Now, and you just have, I have power going to both of these. 5 volts is connected to ground over here, so you grab negative 5 off of here, you just hook it to your negative 5 lug on here. And then I just have 12 volts ground and 5 volts on this one. Yeah, interesting. Yeah, it's kind of weird. But it works. Okay, I got my new power supply set up, all squared away. Donkey Kong. So yeah, this is how I got this done. This one is my negative 5 supply right here. I've got the ground going, or the 5 volt output going over to ground on this one, and I'm taking all of the other voltages off of this. I'm taking 5 and plus 12 off of this, as you normally always would, and I'm taking negative 5 off of this, but I've got this connected to ground. So that's giving me negative 5 volts. And I've got just, you know, power jumped through. So both of them power on at the same time. I just have a negative 5 that's adjustable now. So I got a negative 5 supply and a 12 and 5 supply. And that's my negative 5 right there. So I'm going to monitor this for a little bit, and as I'm kind of curious as if there's something once it gets hot on this board which just kind of shorts out or something and pulls the negative 5 right down. I'm kind of curious about that. If that happens with this setup, because I know I have plenty of current for the setup to run this -5 now. So I'm going to just kind of monitor it for a little bit and make sure that it actually works correct. Alright, yeah, this thing has been on now for just under an hour, about 55 minutes. And we are still holding right around that 4.82. This is not the greatest meter, but it's still, that's it. That was the fix. Having a dedicated -5 supply was the fix for this. It's ridiculous that you got to do that, but this thing's all ECL. That's just it's a power hungry, and that's all there is to it. So there you go. I'm going to go ahead and I got to take this all back apart because I'm going to work on this now that I can actually run it. But I'm going to upload this as part 1 because I've got quite a bit, and just quite a bit of trial and error type stuff and a little bit of repair type stuff, but a lot of this was my power shenanigans and stuff like that. And yeah, I looked this thing up right here. This power supply that I took down, it's still good. This is rated at 1 amp on the -5 rail. Most of these switching power supplies are rated 1 amp. And that just will not cut it for this board. So this is the fix. This is what I had to do. So I'm going to go ahead, upload this one. Stay tuned for part 2 when we will dive into why this looks like this.